Hi everybody, today we're going to talk about the Central Limit Theorem. In this video, I'm going to show you how to use Excel, but I'll have a second video if you prefer using Desmos. We're given a population follows a normal distribution with a mean of 199.6 and a standard deviation of 44.9. We want to find the probability that a single randomly selected value is less than 205.4. So to find this probability, we're going to go to Excel and we're going to use the command normal.dist. Now remember, when we're using normal.dist, we need to put in the value we want, the mean, the standard deviation, and for cumulative, we write true to say give us all of the data to the left of that value that we start with. In this case, we will put in normal.dist with 205.4, 199.6, 44.9, and then true. But to see that better, let's go directly to Excel. I brought over all of our information so it's easy for us to look at. I'm going to go into this blank cell and type equals. I start typing norm and I can see below norm.dist comes up, so I'm going to double click on it. Then I need to put in my 205.4. I put in the 199.6 mean, the 44.9 standard deviation, true to get the cumulative probability. When I push enter, it says 0.55139. I'm going to call that 0.5514. Now that we have our probability that x is less than 205.4, being 0.5514, let's move on to our next question. We want to find the probability that when we take a sample of 213 randomly selected items from this population, we want to know the probability that this sample of 213 has a mean less than 205.4. So we're not finding the probability that x is less than 205.4, we're finding the probability that x bar is less than 205.4. Here we're using the Central Limit Theorem, so we still get to use our same mean, but we don't get to use the same standard deviation. We're going to use the standard error of the mean. So the standard error of the mean takes the standard deviation and divides by the square root of the sample size. So this time we have a sample size of 213. We will divide 44.9 by the square root of 213. Over in Excel, we're going to use the command norm.dist, 205.4, the mean 199.6. Then we'll put in the 44.9 divided by SQRT of 213. That's our square root of our sample size, and then true. So it looks very similar to what we did in our first problem, but with the square root of 213 to show that we're looking at the Central Limit Theorem. So for clarity, I'm putting in probability that the mean is less than 205.4, so we can see that we're not looking at x, we're looking at x bar. In my empty cell, I type equals. I start typing norm again, I get to my norm.dist. Double click. Back to the 205.4, comma, 199.6, comma, 44.9, divide, SQRT, parentheses 213, in the parentheses, comma, and then true to say cumulative, we get 0.9703. Again, let's write that in. Now let's stop and talk about what did we just do. The first time we found the probability, we found the probability that a single value x is less than 205.4. The second time, we found the probability that the mean of our sample that we drew is less than 205.4. Let's try a second example. This time, a study found the average sleeping heart rate of a child between 8 and 11 is 89.1 beats per minute with a standard deviation of 8.2 beats per minute. If we assume the heart rates were normally distributed, we want to find the probability that a randomly selected child would have a sleeping heart rate over 95 beats per minute. We are looking for the probability that x is greater than 95. I want to remind you that Excel gives the cumulative distribution to the left. It tells us what's less than a particular value. So when we want to look at things that are to the right, we need to subtract for 1 to get the probability to the right. We just make a little adjustment in our calculation. So we're going to do 1 minus norm.dist of our value 95, 89.1 mean, 8.2 standard deviation, and true. So just remember, when you're going to the right, you do 1 minus to get your answer. Let's go try that. So in my cell, I type equals 1 minus to say I'm going to the right, norm, and I see my norm.dist that I can pull up. 95, our value we're looking for, 89.1, our given mean, 8.2, our given standard deviation, true to get cumulative, and it says 0.2359. Again, the second part is going to be about the central limit theorem. So now we're going to select a group of 67 children. Then we want to know what's the probability that the average of their heart rate is over 95 beats per minute. So when we're looking at the probability that x bar is greater than 95, using the central limit theorem means we're going to find 1 minus norm.dist of 95, 89.1, but now 8.2 divided by the square root of 67. So back in Excel equals 1 minus norm.dist, double click, 95 our value, 89.1 our mean, 8.2 divided by SQRT of 67, close parenthesis, comma, true. This says 1.93728 E with a negative 0.9. This means this is a really small number. It went into scientific notation. Essentially, this number is 0. It says the probability is so small that they had to use scientific notation to express it. Kind of expect, if it turns into scientific notation, you see an E with a negative, you can just write 0 in as the answer. You don't have to be able to convert it back to this 0, 0, 0. You can just say, look, that's so small, I can put a 0 in my answer. So here, to overemphasize it, you can see I wrote the probability that x bar is greater than 95 is 0, saying we don't expect that to happen at all. So let's do one last example. The average time to run a marathon for a person 30 to 40 years old is 4.4 hours with a standard deviation of 0.25 hours. Assume the distribution of time to finish a marathon is normally distributed. We're going to find the probability that a runner finishes a marathon between 3.8 and 4.2 hours. So the first thing we're looking at is x being between 3.8 and 4.2. Remember, Excel is doing one value at the time, so when we're given two values, we need to subtract the two areas. We put the biggest one first. So we're going to do norm.dist of 4.2, 4.4 with 0.25 true. Then we subtract norm.dist 3.8 of 4.4 with 0.25. This lets Excel do the heavy lifting of finding each region and then finding the probability that the value is between those two numbers. So in Excel, go to your blank cell, type equals, start typing norm, double click on .dist, put in your larger value, which is 4.2, the mean 4.4, standard deviation 0.25, then true. Close parenthesis, hit minus. Start typing norm.dist again. Put in your smaller value 3.8, back to the mean 4.4, standard deviation 0.25, also true, close parenthesis, push equal. Making that bigger, you can see that this is 0.20365. I could call that 0.2037. Then our last part says find the probability the mean running time for a group of 15 randomly selected runners is between 3.8 and 4.2 hours. Now we need to use the central limit theorem, where the standard error of the mean is the standard deviation 0.25 divided by the square root of 15. So in Excel, again, we're going to find the difference between the two areas, but you're gonna put in divide by the square root of 15 in both of the commands that we did the first time. So we're going to type equals, and we're doing the norm.dist, and we're starting with the bigger number, 4.2, average 4.4, but remember, standard deviation 0.25 divided by the square root of our sample size of 15. Then we put true, close parenthesis, and say minus. Now we're doing norms.dist again. We go to our smaller value, 3.8, mean 4.4, standard deviation, we do 0.25 divided by the square root of 15. Then we put true, close parenthesis, push equals. we get 0.00097. If I round to 4 decimal places, 1, 2, 3, 4, it pushes it over to 0.001. This has the probability that the mean time for this group of 15 runners being between 3.8 and 4.2 hours is 0.001. As a recap, I really want to stress that when you're finding the probability for a single value, you use the normal distribution. When you find the probability for the mean of a sample, think a group, then you're going to use the Central Limit Theorem, and you have to use the standard error of the mean. Remember, you can come back and watch this video done all again using Desmos instead of Excel so that you have choices.